myself Dr. Bharati Patil. We have started our chapter related to our subject electronics, and in that we have started number systems and logic gates. Up till now we have covered various points related to number systems, and these are related to decimal number system, binary number system, their respective conversion, then hexadecimal number system, hexadecimal to binary, binary to hexadecimal, then hexadecimal to decimal we have seen. Now in today's lecture we will see how to convert decimal to hexadecimal number system. So we know that in case of decimal number system its base is 10. In case of hexadecimal number system its base is 16, and now we have to convert a given decimal number to its hexadecimal form. I have also told you how to generate this table. In order to have 16 various symbols, we have taken in decimal number systems total 16 symbols, that is 0 to 15. Actually decimal number systems is restricted from 0 to 9. Then corresponding hexadecimal numbers are 0 to 9, and after that we have to add A, B, C, D, E, F, that is there are 16 symbols. Then binary equivalent number of these are given in terms of a nibble consisting of 4 bits, and I have already told you how to generate that binary numbers instead of reciting them. So you can write 8 zeros initially and 8 ones. After that 4 zeros, 4 1, 4 zeros, 4 1. Then 2 zeros, 2 1, 2 zeros, 2 1. Then 1 0 1 1. Like that you can easily recite this whole table in order to convert hexadecimal to decimal or decimal to hexadecimal number systems. So our given number is 2598.675, which is in decimal number system, and we have to convert it into hexadecimal number system. This number is a mixed type of number. In case of decimal number system, this is called as decimal point. Suppose it is in hexadecimal form, then it will be called as a hexadecimal point. So this part is integer part and this part is fraction part. So we will try to solve integer part and fraction part separately. Suppose there is only integer and we want to convert it into hexadecimal form. Then at that time you have to divide that integer with 16, and you have to write the quotient and remainder separately, and you have to again you will obtain a different quotient, and to that quotient you have to again divide it by 16. Then again you will obtain a different remainder and quotient, again that quotient you have to divide by 16. So you have to continuously divide or successively divide the obtained quotient till the quotient becomes 0, and you can convert the integer part of that to a hexadecimal form. Suppose there is a fraction part of decimal number system and you have to convert it into hexadecimal form. At that time you have to take that fraction part, and to that fraction part you have to multiply by 16, because in case of hexadecimal form there are 16 symbols and its base is 16. So you have to multiply that fraction by 16, and again you have to write down the outcome of the that multiplication or product as a fraction and an integer part, and that integer part will be taken as a carry. I will explain you how to find out this separately. So let's start to find out the value of or conversion of 2598 to hexadecimal. 2598 to, suppose it is in decimal form, to hexadecimal. So in order to take this, you have to take number 2598, then divide it by 16, then you will obtain a quotient and remainder, and here you can have equivalent hex number. So in first step you have to divide it by 16. When you divide it by 16, the division or the quotient comes out as 162 and remainder comes out as 6. Again what you have to do, as the quotient is non-zero, so we have to take that quotient again and divide it by 16 again. When you divide it by 16, then quotient comes out as 10 and the remainder comes out as 2. Now, as the quotient is not 0, you have to take that number or quotient and divide it by 16. So, when you divide it by 16, it is not possible to divide 10 by 16 because it is not perfectly divisible. So here quotient comes out as 0 and our remainder comes out as 10. So as the quotient comes out 0, you have to stop now. So after that you have to look into the table or column of remainder, and these bits are very much important in order to get its equivalent hexadecimal number. So here one can have 6. 6. Equivalent hexadecimal number of 6, it is in decimal, and 6, where is 6? 6. So its equivalent hexadecimal number is also 6. So you have to write here as 6. Now next remainder is 2. So it is in decimal. So for decimal equivalents, hexadecimal number comes out as 2 here. Now next is 10. 10 in decimal. Now you have to find out its equivalent hexadecimal number. So you have to look 10 in decimal and its corresponding hexadecimal value is A. So you have to write here A. Now you have got the bits, but how to write it? Means from here 6 to A or A to 6. So we have to remember that if we are representing an integer part, then the lower value will become as most significant bit, and the upper value, this, will become as least significant bit. And while writing the number, you have to move from most significant bit to least significant bit. So it give me, if my number is 2598 in its decimal form, then its corresponding hex number comes out as A26, and it is in hexadecimal, so I can write here 16 or I can write here H. So you can write here H or you can write here 16. So first part we have finished. Now we have to focus on the second part, that is fraction part. So fraction part is 0.675 and I have to convert this fractional decimal into its hex value. Just now I have told you that while converting a fraction value to its respective hex value, we have to multiply by 16. So we have to multiply it by 16. So what we have to do now, our fraction part is 675 and it is in decimal form, and you have to convert it into hexadecimal form. So now what I have to do, I have to convert it into hex number. So I have to take this number, this is to hex number. This is my question. So I have to take this number and I have to multiply it by 16. So when I multiply it by 16, its value comes out as 10.8. Now to this 10.8, split it into a fraction part, 10 as a carry, and or write first here fraction part, because in previous fraction and carry. This is for simplicity we are doing. So fraction part is 0.8 and carry will become a 10. Then next we have to take this fraction and we have to multiply it again by 16. So this gives me value as 12.8. So again, if I differentiate it into carry, then this 12 will become carry as it is an integer part, and 0.8 will become a fraction. Now again, I have to take this 0.8. Again, I have to multiply it with 16. So again, by multiplying the same calculation, so I will going to obtain 12.8, and I have split it into a fraction part and an integer part. Again, I have to take this number and I have to multiply it with 16. It again give me 12.8 and here 0.8 and here 12. So I have complete a bit. I have complete a bit because it is a nibble. It consists of 4 bits. So I will stop now, and now this carry column is most important in order to find its hex equivalent. So hex equivalent number. So again I have to move towards the hex equivalent number 10. Means 10 in decimal, 10 in decimal, and I have to write its respective equivalent value of hex number, and 10 represents A. So I have to write here A. Now 12. 12 in decimal. Where is 12? 12. Its equivalent hexadecimal is C. So instead of 12, I have to write C. Again my number is 12. So I come to know that it represents a C. Again for this 12 there is also a C. So now I have obtained the 4 bits related to my equivalent hexadecimal number, but I don't know whether I have to write it as ACCC or CCCA. As it is a fraction part, as it is a fraction part, so while considering a fraction part, you have to write its answer as, I will write here. As it's a fraction part, while writing a integer part, this has become a more significant bit, and this has become a least significant bit. And here, while writing a fraction part, you have to write means 0.675 in decimal, and you have to write its equivalent hex number. So this will become a most significant bit, and this is least significant bit. So you have to write the number as ACCC. So here 0 point something. So you have to also give a point, and number will become ACCC, and it is in hexadecimal form. So I have fragmented or bifurcated the given number into an integer part and a fraction part, so that suppose there is no a mixed number and they have given us only such type of example, you can find its answer easily. And suppose they have given you this type of fraction to convert to its hexadecimal form, you can easily obtain its value also. While obtaining the value of integer part, you have to continuously divide by 16 till the quotient remains 0, and while converting a fraction part to hex number, you have to continuously multiply by 16. At least you obtain a 4-bit number or a 8-bit number. So we have obtained this number and this number. But my question is not to convert 2598 to hex number or 0.675 to hex number. My question is to convert 2598.675 to hex number. So what will my final answer? So my final answer for the question will be 2598.675 in decimal will represent, my first part is A26 and my second part is point ACCC in hex number. So this will be my final answer. So students, I have tried my level best to make you understand how to convert a decimal number to its hexadecimal equivalent. Hope you understood the same.